This meeting is being recorded.
In this last video for Chapter 12, we're going to cover both Section 12.12 and 12.13. This first section that we'll review, there's not too much information regarding the oxidation of phenol. You will not need to know all the details of cellular respiration, just mainly this reaction here, where phenol we may think to be unreactive in this type of situation as far as it would not oxidize, because we've seen that with tertiary alcohols, for example, there's no alpha proton available. And that has been a requirement that we saw for primary and secondary alcohols to undergo oxidation. But phenol is actually found to be more reactive. So under these oxidizing conditions here with our chromic acid, we can see that phenol will interconvert to a benzoquinone, shown here, and it would oxidize, and then that benzoquinone would interconvert to a hydroquinone. So we see through reduction, we can produce this hydroquinone. The name implies that we've added some hydrogens, and then through the process of oxidation, so this arrow should be pointing this way, we'll see that we can return that benzoquinone structure. And again, you won't need to know all the details of cellular respiration, but this reaction is part of the process. So these ubiquinones, as they're called, these act as catalysts in the conversion of oxygen into water, and the name may imply that they are present widespread, and they are found in all cells in nature. So they are quite ubiquitous, so hence the name ubiquinones. Let's see, we have the process here of catalysis, where you will not need to know these two steps in detail, but we can see that ubiquinone just works as a catalyst. It's returned. It's not part of the net reaction. So that brings us to the second part of this video, where we can review some synthesis strategies. So far, we've covered ways that can convert from alkynes to alkenes and alkanes, depending on what reagents are used. And in general, we know that reactions fall into one of two categories. We can change a carbon skeleton, or we can change a functional group. Change or move a functional group, right? So we have our alkyne over here. If we perform an dihydrogenation with Lindlar's catalyst, we can stop at an alkene. If we do just a metal catalyzed hydrogenation, we'll fully reduce our compound to an alkane. And then we could do the reverse. We could do a radical bromination, shown here, Br2 with light, and then an elimination using sodium methoxide, and that would bring us from an alkane back to an alkene. And then we could do bromination, and then with excess sodium amide, we could do two subsequent eliminations, and then protonation with water to produce an alkyne. So these are the reactions that we've covered so far to convert between alkynes, alkenes, and alkanes. We've also seen multiple reactions now to interconvert primary alcohols to aldehydes and secondary alcohols to ketones. So that's what we see up top here. We see this aldehyde product with the PCC, and then we can convert back using the reducing agent lithium aluminum hydride. Then below here we have chromic acid as our oxidizing agent to produce our ketone. And then we have the same reagents to go back and reduce it back to an alcohol. So primary alcohols, aldehyde products, secondary alcohols give us our ketone product. And this next slide shows how we can group these 6 functional groups into categories based on oxidation or reduction being an intermediate between them. So if we start over here, for example, on the right with an alkane, through oxidation, we can think of oxidation as lowering the number of hydrogen bonds or increasing the number of oxygen bonds. So we're going to decrease the number of hydrogen bonds to go from an alkane to an alkene, and we'll directly increase the number of oxygen bonds with alcohols. And similarly, if we increase a carbon bond to a halogen, we also will see, as with our alkyl halides, an oxidation occur. So if we take one of these intermediates and they undergo oxidation, or one of these alkenes, alcohols, or alkyl halides rather, through oxidation again, we can produce the alkyne, or we could oxidize, as we just saw, primary or secondary alcohols to produce those ketones or aldehydes. And then the reverse will take us one step at a time to a full reduction would return those alkanes. So this is an overview of how we can convert functional groups. So we see everything from hydrogenation, bromination, followed by elimination. Depending on what your starting material is and your product, your goal, you can use this slide as a reference when you're interconverting. So this will be a very useful slide on an exam. Per se. So I would maybe have this handy for your first test. So that way you can say, all right, if I start with an alkyne and I want to produce an alkene, I'll need a poison catalyst. Or do a sodium metal reduction, something like that. So this slide is very useful and a quick reference for multiple reactions shown in one place. The last reaction specifically that we'll review here is the Grignard reaction, and we can see here this works with ketones, it works with aldehydes, and it works with esters. But we saw that it cannot work, so not compatible with either alcohols, right? So they have acidic protons or acids. So we have to, so even water, right, is a no. It's not a good solvent for these types of reactions, but we can see with ketones, we create a new carbon-carbon bond. So we add this methyl group because of our specific Grignard reagent that's used as a methyl group. And then we also form the alcohol product. So ketone, secondary alcohol. What do we have here? We have an aldehyde in the second category. So we add that methyl group. We convert it to be a primary alcohol. Or I'm sorry, this is actually a secondary alcohol as well, because we've added on that, that methyl group. And then last but not least, we have our ester conversion. So we use excess Grignard reagent now. So we've added 2 of those methyl groups. We've converted it to our alcohol. And if you recall, we also have that other byproduct of methanol. So sometimes we'll see multiple steps needed to fully convert our reactant to our target product. So we see here that there's no direct reaction, like a single reaction, that will convert an aldehyde into a ketone. So we cannot directly convert our reactant here to our desired product. So what we can do is use a Grignard reaction, attack with a Grignard reagent. We see that here, and followed up by water as our proton source to produce this structure, or rather to produce this structure up here, right, after steps 1 and 2. And then we can use our oxidizing agents down here, that chromic acid, to perform an oxidation. So we did a Grignard reaction and then oxidation, and we can end up with a ketone that we're looking for. So we'll practice many more synthesis problems with the videos on the Chapter 12 practice problems.